Today we're going to be talking about slope and rate of change. Slope is the rate of change in a relationship. Slope or rate of change is a ratio of the following: change in the dependent variables over change in the independent variables. What is dependent? It's the y, isn't it? The output. What is the independent? It's the x, the input. Okay? So on a slope of a linear relationship, slope describes the steepness of a line. Okay? So let's look at this. When we go from left to right, our slope goes uphill, doesn't it? So a positive slope increases from left to right. We're going from left to right again, and our slope goes downhill. So therefore, a negative slope decreases from left to right. Okay, and horizontal. So a horizontal slope has zero. It's a zero slope. It's a horizontal line, so there's no change. It doesn't go up, doesn't go down. It just stays at zero. And here's the one that we need to really kind of wrap our mind around also. A vertical line is an undefined slope of a vertical line. Okay, so now we're going to be looking at what we've got down here, and so just the different lines. So let's look at line A. Line A is what kind of a slope? Line A didn't go up, didn't go down, so it is a zero slope. Line B, when we go from left to right, we're going downhill, so it's a negative slope. Line C, we're going just straight up and up, down. If we fell off a cliff, we would call it an undefined experience. Undefined. And line D, when we're going again from left to right, goes uphill, so it is a positive slope. Example of zero slope might be 0 over 4. That would be a zero slope. An example, a negative slope might be negative 4 over 3. And we could remind ourselves that we could say that's the same thing as saying negative, or I'm sorry, 4 over negative 3. Let's rewrite that. Okay, so the negative could be negative 4 over 3. We could also write that as 4 over negative 3. But normally we just write it like this. We have one negative. Oops. Negative 4 over 3. Undefined is anything over 0. So we might write an undefined. Let's go ahead and change the colors here. Okay, so undefined would be anything over 0. 5 over 0, that's undefined. 3 over 0, that would be undefined. And a positive slope could be, let's say that we might call it 3 over 1, which is the same thing as 3 equals 3. We might find it to be a negative 3 over negative 1. And remember, a negative over negative gives us a positive. Okay, so list any strategies to help you remember the difference between a graph with an undefined and zero slope. So we could say an example could possibly be, you remember REME C-R-E-M-B-E-R, and undefined, an undefined slope. Let's just underline that undefined there. An undefined slope is straight up. So there's our U again. Just find something to help us, remember what we're doing. So there's the straight up. Just give me a line. Up and down. And down. Okay? And horizontal, let's just highlight that Z. Horizontal have a 0 slope. Have a 0, so there's that Z kind of being repeated. Okay? And lastly, okay, to find the vertical value of the slope from a graph, find the ratio of the vertical change compared to, and when we say compared, that means divided by, the horizontal change. And remember, change, does that mean adding or does it mean subtracting? It means subtracting, okay? So when we see change, that means subtract compared to horizontal change. And these are our words that we'll be using a lot when we're talking about graphs. Rise over run. Okay, to do this, count any 2 points on the graph. Then draw a right triangle to count the rise and the run. Always simplify. It's not correct unless you simplify your ratio when possible. And remember to check if the graph has a positive, this is really important, students, positive or negative slope. Okay? So follow the steps to find the slope on the graph shown. The rise of the graph is shown. So you can see here is our rise, there's our run, and we have created now a right triangle. We always want to check to see this graph is counting just by ones for the y value, counting by ones on the x value. That will not always be the case. Rise. So the rise, 1, 2, 3, 4. So we've got 4. The run of the graph, 1, 2, 3. That's the run. So again, this is going to be our vertical change. This is, the run is our what? It's our horizontal change. Okay, so the slope of the graph is 4 over 3. Okay, you always have to find 2 good points. On we're going to draw a right triangle right here. Okay, rise is 1, so rise is 1. Run is 1, 2, 3, 4, and I can see that this is positive. So therefore, our slope is 1/4. This next one, you need to make sure that we find 2 very good points. We can't always identify good points. It looks like our y-intercept is at 7, and I can follow down and say there is another good point, it appears. My graph is a little bit, or my pen is a little bit off, guys. Just have to go with that. Okay, so let's make our right triangle right there. Okay, so we went up 1, then we went back 1, 2. Okay, so our rise is 1. Our run, and it looks like we went backwards. Let's look and see, does this, when we go from left to right, is our slope going uphill or is it going downhill? And we can see that it's going downhill. And so this has to be negative slope. negative. Okay, and so we've got a negative 1/2. Okay, again, you're going to have to find two good points. It looks like we began at the origin here. Looks like that's another one. Looking at, we can see that our x value counts by ones. 1, 2, 3. Our y value does not do that. Our y coordinate's going to count by threes. So we're going to make a right triangle. And so here we go. Let's see, that's too close to the same color. Okay, so our right triangle. And we're going to look and see how we rise. 3, 6, 9. So our rise equals 9. Run, we're counting by ones. And so we go 1, 2. And that's going to be, looks like our slope is going uphill. Uphill, so it's positive. Okay, so we've got 9/2 is our slope. I'm going to let you do the other ones, and I hope you guys have a good day. Thanks.